Well, good afternoon. Oops, there we go. All right, let's get started. So we started on Monday talking about objects and classes and went through this memory example. What happens when you declare objects? What happens when you actually create an object in terms of memory allocation? And are there any questions about that? Because we'll go through some code examples and then I'll refer back to this in terms of what's happening with the memory as the code executes. And then we talked about the basic relationships. The has a relationship, the is a relationship. Has a relationship is where one object contains another. So if you're in one class, you're building an object and you use the new keyword, that class contains an object of another class. That's a has a relationship. The is a relationship is inheritance, which we've talked about before and we'll talk about more. And next week, we'll get into even more details about the inheritance relationship. A reminder that the has a relationship can be nested. So here I've got top, middle, and bottom for my classes. And top has a, notice the term has an instance of the middle, and the middle has a instance of bottom. And what I'm recommending is that you don't try to talk to classes that you don't directly contain. So if top has the middle object, it should only speak to the middle object. It shouldn't reach through and try to get to the bottom. Instead, let the middle do that. It's the middle's job to manage the bottom in this situation, and so you should ask the middle to do that and let the middle do the managing. I had a student ask a question because in his project, this kind of thing where they actually do reach through is the norm for the game that he's creating. He's basing it off of another game, and so it's legal. You can do it. It's not technically wrong. You don't get points off. As a general rule, though, it's not good design, and it can lead to more frustration in your code development, error checking, code maintenance, all those non-functional things that we look at. And as a reminder, you can create arrays of objects, but when you create an array of objects, when you first create the array, what you've really created is a warehouse that can store the objects, but you haven't created any objects yet. So the example I used here, zombies equals new zombie, or 100, so I've created an array of 100 elements, and that there are no zombie objects in that array yet. It's the equivalent of when I create an array of integers, they automatically get assigned the value of 0 initially. When I create an array of doubles, they get assigned the value of 0 initially. And here, you create an array of zombies, and the handle, remember the name of the thing is always just the handle to the object, and the handles are initially set to null, which is the equivalent of 0. So what do? You have to go through and actually create each one individually. And even here, I've got several lines of code. Inside main. Inside main, I create the zombies, and then I go through this loop inside main. I'm recommending that inside main, you try not to do any work at all. You always use a method call. So I would actually have done if this wasn't an example for class, I probably would have had a create zombies method or a fill the zombie array method or something like that. Initialize zombie array and do it all outside. The is-a relationship is where we have inheritance. And so here I have phi, phi, fo, fum, and phi is the base class, it's the generic class. Phi extends phi, fo extends phi, fum extends fo. You can just keep doing that and keep extending as much as you need to. Now in your projects, you're probably only going to have the first two layers, your generic object and then your specific. Your generic class and specific class. But you may find that even in your project, you might need to go another layer down, and that's not a problem. The biggest thing about inheritance to remember, though, is when do you do it? When do you know you want to use inheritance? When you have similar objects with different behaviors. And by different behaviors, I mean that they have the same methods in terms of the name of the method and the input to the method, but they actually have different lines of code in the body of the method. That's how you know. If you're not changing the lines of code in the methods, there's almost certainly no good reason to use inheritance in that situation. And I've made that comment on your P1 deliverables for quite a few people. It's normal, I think, the first time you go through this to think about changing behavior in terms of changing the attribute values, but that's not what inheritance is about. It's about changing the behavior in terms of the methods and the way they operate. So let's pause for questions. All right, let's get into code examples. So I've got some code examples. You have these, and my recommendation is to play with these things. I've got a generic shape, square shape, circle shape, rectangle shape, and then I've got a shape controller, the thing that actually will do stuff. And when you're creating these things, you kind of have to ask yourself, all right, I've got some objects that are similar. I probably should use inheritance. I should probably have a generic version of this thing. And then you ask yourself, what attributes would be common? What is it that everybody has? Okay, so I'm thinking in terms of shapes. What is it that everybody has? Everybody has an X location and a Y location. That I know. And what the heck, I'll give everybody a name. So everybody has a name. Then you ask, okay, in this case, everybody has an attribute. Everyone would have an area too, and everyone would have a perimeter. That's true of all shapes, all 2D geometric shapes. Why don't I include area as an attribute? Can anybody guess why I didn't include area as an attribute? It's a guess. You won't be held accountable. It's okay to guess. It is completely on the, yeah, exactly. It's dependent on the other attributes, and you can calculate it. So if you can calculate something based on the attributes you already have, then you shouldn't store it. And the reason is, let's say we did area for a circle, and the circle has a certain radius, and we calculate their area, and then we store the area in the attribute value, and then we change the radius. Now that area is no good anymore. So rather than storing it into an attribute, it's better to just recalculate it every single time you need it. Because you know if you recalculate it, you're using the correct value for the radius at that time. Okay, then I extend this, and let's go with circle shape because it's more developed. So I extend this thing, and a couple things. The generic shape has how many attributes? 3, right? X location, Y location, and object name. And then circle shape, and this is how you say it, public class circle shape extends generic shape. Private double radius. So what I did for the circle is, because it needs to have a radius, I added that as an attribute. You are allowed to add attributes. And it was a struggle for me to try to say, man, should I put that in the circle class or the generic class? So for example, in the generic class, I could have had attributes for dimensionality of the shapes. I could have said dimension 1, dimension 2, dimension 3. I could have put in radius, side length, things like that. But it gets down to a design decision at that point, and it's not trivial. It's rarely in a case where there's exactly one right answer. It comes down to design style and design decision. So this is where you start to have some real head scratching going on, and it's normal. You know, I do kind of hope you struggle with this sometimes during your project, because by struggling, it means, you know, normally that you're learning, right? That you're going beyond the boundary of your comfort zone. So I decided to put all the elements that were unique to each shape in each shapes class. So how many attributes does the circle shape have? Four. It's got the original 3 because it inherited those 3, and then it's got the 4th one added to it. So there's actually 4 attributes here. Now up in your, oh, and by the way, my comment blocks are lousy. Yes, I got lazy. This was what, last spring, prior to the pandemic, so I have no excuse. Here are my attributes. I would just list radius. And then I would rely on the parent class, the generic shape, to have the description of the attributes that are actually contained there. Okay, let's talk about the methods. If I go back to my generic shape, now I've got 3 attributes: X location, Y location, object name. For every attribute, virtually every attribute, I should say, this is going to be true, you know, 99% of the time. You should have you set your attributes private, but then you make your setters and getters public. So I have a way to set the X location value. I have a way to get the X location value. I have a way to set the Y location value and a way to get the Y location value. I have a way to set the object name and a way to get the object name. So I have 3 attributes. I should have 3 setters and getters. The technical correct term for these are accessors and mutators. The accessors are the getters. They can access the thing. And the mutators, mutation means change, right? The mutators mutate or change. Those are the setters. So, you know, that's the legitimate reason why you paid your tuition college words is mutators and accessors, but everybody says setters and getters. And everybody uses this set X location, get X location. You don't have to, but you won't get hired if you don't, right? Because everybody uses these. This is part of the please name your code, please name your methods what they do, and everybody use set and get. It's like using I for a loop counter. It's just done. So you'll have those in all of your classes, and those are not the most interesting methods. The other interesting methods are, okay, once you determine that you're going to have a class, then you start to ask yourself, all right, if I think of this class as how people might use it, right? So I have a generic shape. That's right, and that's why you have to make the decision. So it is not bad practice. You need to have a rationale for it, but it's not bad practice. And so you may have attributes that truly you only want to be referenced internally to that class, and you would not do a setter getter for that. But the rationale for that doesn't show up all that often. Again, it's a design decision. And as a reminder, why do this? Why not just make the attribute public and people can set the X value directly? Why go the extra heartache of creating a method to do this? Well, the reason is, and I haven't taken advantage of it here, remember the number one benefit of the object-oriented paradigm is this data encapsulation. It's your data, you protect it. You get to say who touches it and who doesn't. And so if you don't want anyone to touch it, don't do a setter or a getter for it. But you also get to say how it's used. So for instance, in X location, Y location, I can probably accept any value that I want. But when I do circle radius, I probably don't want people to give me negative values for the radius. So I could check for that if I wanted to. And so I can control how these things get changed. If it's an aircraft, you know, you don't want people to give an aircraft an altitude of negative 10,000 feet. That's probably a bad idea. So you get to control that. If it's a mass, you probably don't want negative volume. If it's supposed to be, you're modeling a sofa, you probably don't want a volume of 10,000 or 10,000 cubic miles. So the idea is, by making people go through the setters and getters that you created, you have the capability to filter the values so that you don't get these crazy out-of-bound conditions in your programs. You know, you don't get really ridiculous results. So it is a code correctness and code robustness, because sometimes bad values will cause errors, and even a security check. Okay, once I get this far though, I say, okay, I've done my attributes, I've done my setters and getters for the attributes, and now I need to figure out what will people do with a generic shape. So if people have a shape, you know, again, they're gonna have a square or a circle or a triangle, what kinds of things do they want to know about it? What kinds of things, how will they use this thing? And all I came up with was area, perimeter, and center of mass. You know, there may be more. You might think of more. But think about when you're designing your classes, how are people going to use this? If you think of the class as a service provider, what services should it provide? If you think of it as an object, what kind of actions will people ask that object to do? Or what information will people want to know about that object? And that's how you come up with your methods. And it's not trivial. And it's one of the things that even after, you know, even professional code designers will struggle with. Okay, what should the methods be, and which class should have the methods? So I've got 4 methods that are real. I mean, in addition to the setters and getters, which I'm ignoring, I've got 4 methods. Now let's go. I'm going to go do square shape just for a second. So here's square shape extends generic shape, and we added, instead of radius, because it's a square, I did side length. So how many attributes do we have? 4. The original 3 from the generic class are inherited, plus side length, which is the 4. And I don't have any methods in here. So how many methods does this class have? If my count is right, it's 4. Because it inherited all the methods from generic shape. 1, 2, 3, 4. Yeah, 4 methods. In addition to all the setters and getters, of course. So there's 4 methods. Now, the calculate area for the generic shape, I made it just a generic method. I mean, so if you run this, if you try to run this code and you run calculate area, it will say, hey, calculate area is called for generic shape. Please overwrite this method. It means, you know, this method is not good. It's not giving you good data. And so I'd return -1 as kind of a clue. Hey, it has to return something, right? So I give it a -1 because you should never have negative area. So what I do is I create the methods, but often they're dummy methods at the generic level or default methods. And then what do I need to do? Oh, I need to do what's called overwriting. I need to modify those methods. So if I look at circle, where I've done this, calculate area, I've actually put the correct formula in there. Calculate perimeter, I've actually put in the correct formula for a circle. And I would have to do that for the square and for the rectangle also. For the circle, the center of mass is just the X and Y location. By the way, when I calculate area, I'm returning a number, right? A number, so it's a double. And when I'm doing calculate perimeter, I'm returning a number, so it's double. But when I calculate center of mass, I'm returning two numbers, an X location and a Y location. So what did I do? I created a little array of doubles, and its length is 2. First position for the X, second position for the Y, and then I return, I say center of mass, you know, that array value in the 0th position is the X location, that array in the Y, in the second position is the Y location, and then I return that array. So you can pass arrays in and out. Now really, what am I returning? When I say I return that array, I am not returning a copy of that array. I am returning a handle, because the array is an object, a handle to the array object. All right, so we're creating these, or overwriting these, I should say, for the circle. Now for the square shape, I didn't do that. So if I were to create a square and then say, give me the area, it's going to go back here and give me this bad area calculation, because I didn't tell it how to tell the machine how to do it for a square. And the way this works is like this. This is what this slide was not in the original. If I have up in the parent, now remember the parent-child relationship and inheritance, the generic shape is the parent, the square is the child, the circle is the child. If I have in the parent some method foo, and then I have a child with the same method, but then I overwrite the original parent's method, and then I say, you know, child.foo, the Java virtual machine is going to go look in child and say, I'm going to look for this method called foo. If I find it, great, that's what I'm going to use. If I can't find it, since child is a child of the parent, I'm going to go up to the parent and look for it there. So for foo, I have a method up in the parent class and I have a method down in the child class. The Java virtual machine will find that one in the child class and use whatever's there. So in the case of our circles and squares, I've got a generic shape with calculate area in it, right there. And I've got a circle shape with calculate area in it. And the Java machine, if I say circle.calculate area, the Java virtual machine will look in the circle class, look for calculate area, find it, and then use it. But if I did that for a square, since I didn't overwrite the methods, the Java virtual machine would look in the square class, look for calculate area, not find it, but then it'll say, ah, wait, the square is a child of generic shape. Let's go to generic shape and see if there's a calculate area. Then it will find it and run that. If you think of it as a chain, it's always, it starts at the bottom of the chain and looks for the thing. If it can't find it, it goes up one. If it can't find it, it goes up one. If it can't find it, it keeps doing that until it finds the first one. And that's the one it'll use. So far, so good? Okay, so circle shape extends generic shape. What attributes does the circle shape have? X location, Y location, object name. Got those from the parent, and radius. And then I rewrote all of the methods from the generic shape. Now this may seem like a lot of trouble. Oh man, you had to rewrite all the methods. What's the point? Well, this is an example. It's highly artificial. Normally, let's say you have 10 methods for the generic class. Maybe 8 of those are the same for all the children, and you only have to change 2 of them, or you only have to change 1 of them. It's normal that you're going to have a number of classes that do not change for the child. They really are meaningful for the child, and then you only have to change a couple. So you get a lot of value because what you're getting is code efficiency in terms of code production, right? You're offloading all that work from the software developer. They don't have to copy and paste, 8 methods and hope they got it, hope they remembered them all. They get them for free through the inheritance. It helps with offloading work from the code developer. It helps with making sure that there's no typos, right? When I named it calculate area yesterday, if I came back next week and did another object, maybe I'll call it something other than calculate area, find area. And then I've got a problem because I've got 2 different method names trying to do the same thing. Here I get all that stuff for free. It really does help in terms of ease of code development, correctness of code development, and as we'll see later, even robustness of the code that's running. Okay, and then I have a rectangle which I haven't done anything with. So again, my advice to you is, take the square or the rectangle and extend these things and actually fill out some methods for them and play with them and see how they work and how they don't. Okay, now here's a shape controller. Let's see here, shape controller. Let me ask this question first. Circle shape and generic shape, are they related by a has-a relationship or a is-a relationship? It's an is-a relationship, right? It is. So a circle shape is a generic shape. A circle shape is an example of a generic shape. So it's an is-a relationship. Whenever we're using an inheritance, that's the is-a relationship. And the way to remind yourself of this is, you have a generic dog, and then you have a German Shepherd dog. A German Shepherd is a dog. And a dog is a canine. Oh, so a dog is a canine. A German Shepherd is a canine. So if you think of it in terms of like the standard way that we classify things through these branching trees, then it starts to make sense. So a circle shape is a generic shape. It's a more specific version of a generic shape. Okay. Now, shape controller looks like this. And all I do is make some circles and, give them values and print them out. First of all, how many attributes does shape controller have? None. 0. They would be there on line 16. If an object is created, in order for you to have attributes, it has to be created outside of any methods. Look at generic shape. These guys are created outside of the methods. Or I should say they're at least declared outside of the methods. Right? They don't get created or declared inside the methods. They're outside. So the attributes have to be outside of the methods. So for stage controller, I have no attributes, which again, it shows you this is a highly artificial class example piece of code, because rarely would you create a class without any methods. Rarely. We do create circle shape in here. So here's circle 1, and it's an instance of the circle shape class, and it's inside shape controller. So shape controller and circle shape, are they related by a is-a relationship or a has-a relationship? It's the has-a relationship. I spoke too soon. Right? It's a has a, yeah. Because what we can say is shape controller has a circle shape. It's contained, the circle shape is contained inside there. The shape controller class creates an object of the type circle shape. Therefore, shape controller has a circle shape. It's just kind of like here. Would you say that generic shape has a double? Yeah, it's got two variables that are doubles. And here what we're saying is shape controller has a variable that happens to be a circle shape. So this is the has a relationship. This is how you build up complex pieces of software. You have simple, hopefully relatively simple objects, and then you have a more complex object that is built by putting them together. You know, how do you build a car? Oh, you need an engine, and you need doors, and you need a windshield, and you need tires, and you need a brake system. So the car has all those things, all those other systems. All right, so we build this new circle one, and then I'm going to display the shape info, and then I'm going to set its radius and location and name, and then I'm going to display the shape info again, and I calculate the area, but I never print it out. I don't know why. And then I build circle two. So again, in terms of the memory referencing, when I do this circle shape, circle one equals new circle shape, what I'm doing is kind of like on this slide here, where I say, okay, initially I have just the place for the handle. That's what circle shape is. But as soon as I say, I'm sorry, circle one, and as soon as I say circle one equals new circle shape, then I get my memory for the circle. Now, different examples, so different names for the memory. This is going to have X location, Y location, object name, and radius. But as soon as I say that, I get that memory set aside. And then if I want to talk to that specific memory, I say circle one dot set the radius, circle one dot set the X location. So I'm telling you, set the radius for this circle. And then I create another one, circle shape, circle two, and that's going to give me a new portion of memory is reserved for those attributes, and a new handle pointing to that memory. If I just said set radius 20, the Java virtual machine wouldn't know if I meant, wait a minute, are you talking about the radius for circle one or circle two? So I have to tell it, circle two dot set radius. Now here's a trick question. How many objects does shape controller have? Let me narrow it down. How many circle objects or circle shape objects does shape controller have? Three, okay. I'm going to accept 3 as an answer for sure this way. How many circle shapes does shape controller create? Absolutely 3. It creates circle one here, new circle shape, new circle shape, new circle shape. Absolutely creates 3 circle shapes. But how many are active at any point in time? Only 2. I create circle one, and then I create circle two. So I've got 2 separate objects active, and I'm pointing to 2 separate places in memory. But as soon as I do this, circle one equals new circle shape, then that handle to the old memory space changes and goes to a new one. And it's kind of like this example. Okay, here I've got one object, and then I create my second object, and then down here I do this trick where I say object one equals new object. And so now the reference to the old object one, in this case, a reference to our old circle goes away, and a brand new one is active. So technically, I only have access to 2 objects or 2 circles at a time in this example. Because as soon as I say this, circle one equals new circle shape, all that memory that I used to point to is no longer accessible, and I can never get it back. All these values that you set here for circle one, that's in one part of memory. But now I'm saying, forget that. Let's have some new memory. And that memory has not yet been initialized to anything. So what I'm doing here is I'm showing you, look, circle one, right away I'm going to display the information about the circle, and it's going to have null values, right? Nothing. And then I set the values and I display it again. And then I say new circle shape and I display it again to show you that that new memory space doesn't have anything in it. So let's see here. If I do Java shape controller. Okay, so this is the first time we say, let's see if I can get it here. This display circle one dot display shape info, that gets us this stuff right here. And it says this circle shape is named null. And its XY position is 0, 0, radius 0, mass XY 0, 0. Okay, why is that? Let's start with the XY and the radius. Those are easy. I created doubles, right? X location, Y location are doubles, and radius is a double, and I didn't set its value. So if you ever create a double and you don't forget its value, I'm sorry, whenever you create a double, Java immediately sets it to 0. That's its default value. And the center of mass is just the XY location, so that's going to be 0 too. But this top one, the circle shape named null, what's that about? Well, that's the object name. The object name is a string. Well, if I create an integer, Java Virtual Machine immediately sets that value to 0. If I create a double, it immediately sets that value to 0. If I create a string, what's the equivalent of 0 for a string? It's null. It's the null string. So that's the effective, default value for that string is 0. Interestingly enough, the default value for objects is also null. So whenever you get these error messages that say null pointer reference, it means you are trying to access something you have not yet created. Usually it's an array or an object. And then I go through and give it all its values, and it says circle shape is now named Frodo, and it gives me these values and blah, blah, blah. Circle 2, I give it values, so circle 2 looks that. Then I say circle 1 equals new circle shape. And all these values that I did up here are no longer meaningful because circle 1 is actually going to point to this new memory space that has not yet been initialized. And so I'm back to, crap, it's named null again. By the way, let's do something weird here. Circle 2 displays. Let's do this. What if I do here? I'm going to save it. Compile it, hopefully compile it. You're killing me. Okay, so that compiles, and then I'm going to do, and what do you know? I set circle 2 equals circle 1, and then I said circle 1 is a new circle shape. So what's happening? Let's see. Circle 1, I created up here. I gave it all this information. Its name is Frodo. I created circle 2. I gave it this information. Its name is Biff. Then I say circle 2 equals circle 1. Now, I am not saying to copy all of the attribute values of circle 1 into circle 2. I'm not saying that. What I'm saying is the handle for circle 2 is now equal to the handle for circle 1. In other words, they're both pointing to the same memory space. Then I tell circle 1 to point to a brand new memory space. So these last two displays, it should be circle 1 is going to display all my nulls and things because it's a new memory space, but circle 2 should give me all the old circle 1 stuff. 10, 50, 25, and Frodo. And if you look at the result, the very last thing we print out, which is circle, now called circle 2, it's pointing to the old circle 1 memory space. Understanding what's happening in the memory with these things is a good thing to know. because when you have odd program behavior, sometimes that's what's happening. You're not pointing where you thought you were. I'm going to get that back now. There we go. All right, we're going to go through this more next week too, because there's some more interesting things to talk about how inheritance works. But my recommendation for you is to play with this stuff. You know, you have these files. Make your own square shape, fill it out. Make your own rectangle shape, fill it out. By the way, if I do a, let's do a square shape. Down here, if I say, square shape, square one equals new square shape. And then I say square one dot, what was it, display shape info. Now remember, under square shape, I didn't write any new methods. I don't have any methods in there. I don't have, at least explicitly in this file, it doesn't look like I have something called display shape info. Save that, compile it, run it. Oh, what do you know? Display shape info, it's right there. This is a generic shape and you shouldn't be seeing this. Where did I get that? Well, when I said to display shape info for the square, the Java virtual machine went to the square and said, okay, where's that method called display shape info? It's not here, but the square shape extends generic shape. So let's go to generic shape and see if we can find something. Oh, there it is. Display shape info. Oh, this is a generic shape and you shouldn't be seeing this. What's good about this, again, you know, you can build your code framework and your code will run. It won't give you the examples that, you know, the correct results that you want when it's completed. But you can build all your code and do testing on parts of your code, and the other parts of your code won't keep crashing. And if you put in meaningful comments, this is not terribly meaningful, but basically a warning to yourself that, hey, look, don't trust this result. This hasn't been actually written yet. Then that can help you out. I'm going to keep that in there. I'm pausing for questions and then I'll do one last bit before we go. Okay. Now this is a shape controller and I've got something called better shape controller. And why? Well, look, I do all this, here's main, and I do all this detailed work in main. My advice is don't do that. My advice is try not to do any work in main. Instead, just have main be a series of method calls and do all the work outside of main. And the reason is, if you start to do all your work in main, first of all, you're going to get dangerously close to procedural programming instead of object-oriented programming. And secondly, once main becomes 50 lines long or 60 lines long or 180 lines long, harder to debug, harder to update, harder to figure out what the heck is going on. So instead, just talk about the main things, the larger functions that you want to occur, and then call methods that do those functions. So this is better. I'm not going to say it's best, right? It's just better. And look inside main. It's pretty clear, hopefully, to see, oh, build the circles, build the squares, display all the shape information, find the larger area, find the larger area. All of the work is done down here in these methods. Now notice I haven't built them yet, but that's okay. We'll build them next week. All of the work is down. So when I'm looking at my code, the main code, it's about, okay, what do I have to do here? Oh, I have to build the circles, build the squares, display the shape info, blah, 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 right? You're just reading out, again, if you give your methods good names, if you give your attributes good names, then it's clear what you're doing. And then when you need to know the detail of what's happening, you go down into that method. And that method may call other methods, that's okay. By the way, private circle shape, object 1, object 2. Better shape controller and circle shape. Is that a has-a or an is-a relationship? I know that chat light's going to come on as soon as I say it. It's a has-a, right? The better shape controller has a circle. The better shape controller has a square, has a rectangle. If you don't see extends, the only way it's going to be a is-a is if it extends. Better shape controller extends something. So we have a has-a relationship. Notice I'm making all of these shapes that I'm going to deal with, they're all attributes. How do I know they're attributes? Because they're outside of all the methods. They come right after the shape controller definition, or the public class better shape controller line. So these are all attributes. Because they're attributes, all these methods down here automatically has access to those attributes. And yes, objects can be attributes. Now, public static void main. Oh, wait, this is static. That's static. And this is build circles. Oh, wait a minute. That's not static. So what did I have to do? Remember, if a method is not static, you are not allowed to use that method until you build an object of that class. If a method is not static, you can't use it until you build the object. You can't watch TV till you buy a TV, right? So in order for me to use these methods, again, once I've committed that this is a good way to do the code, putting all the work outside of main and doing it in methods, once I've committed to that, what I have to do is build an object of the better shape controller class in order to have access to those non-static methods. The other way to go is make all those methods static. Never do that. That's not a fix. It's a Band-Aid. And eventually it'll get you all wrapped around the axle. So instead I build an object of that class. Now it may seem weird to you that inside the better shape controller class, I build a better shape controller object. And quite frankly, it should seem weird to you, like a self-eating watermelon. But I recommend the way that you view main, the way you visualize main, is that it's actually logically external to any class. So if I think of it that way, like, oh, main is magically floating outside of this class, then it makes sense that main could build an object of that class. And that's not a bad way to think of main. All right, let me show you what happens if you don't pay attention to this. Build circles. Okay, I'm going to save this, and then I'm going to compile it. And look what it says right on compilation. Now, if you ever get this error message, this is what's happening. Non-static method build circles cannot be referenced from a static context. So my method build circles is down here, and it's not static, but I referenced it from a static context. What does that mean? Well, isn't main static? And I referenced it inside of main. Therefore, it's a static context. So remember what that means. What a static method means, we got to go on this just a second. What a static method means is, even before I build an object of that class, I can use that method. And you have to do that for main because it's the very first thing that the program does. No objects have been created yet. How are you going to get a hold of main if it's not static? So you have to have main static. But that should be the only method you have that's static. So if you want to reference the other the other methods, you can build an object of the class that you're in. That's okay. And then call those methods. And those methods, we'll flesh this out next week. Those methods will have access to the attributes. Okay, we're at 50 minutes. Do we have questions before we go? All right, guys. Have a great day. On Friday, we're going to talk about P2 deliverable, and I'll go through the writing examples and talk about not just that this is good and this is bad. Why is it good? Why is it bad? We'll do some of that stuff. I'll see you then.